Have you ever heard the story about a building in New York City that was saved by the question of a student? If you haven't, you should check it out on this YouTube video. It's one of the most popular, and if you've already seen it, you should watch it again because it's an amazing story. My name's Tyler Lay, and I tell these stories on YouTube to try to teach you guys something about structural engineering and concrete. The Citicorp Center is a very unique building. It has a very unique shape. I bet you maybe have seen it before on the Manhattan skyline. Not only is it unique in shape, but the columns at the bottom, again, crazy unique, and they're designed that way for a special reason. If you want to learn more about it, you gotta watch the video. Now, one thing about this that's amazing, this building was open. It was ready to go. People were using it, and a student asked a question to the design engineers. And that question triggered off, oh my gosh, they were right, there's a problem, but the student was lost to history. We don't know who they are. But she found me. She found me, and I get to interview her today for you. And how do I know she's real? Oh, she gave me her thesis. She checks out, ladies and gentlemen. Diane Hartley is the real deal. Check this video out. It's totally amazing. Hey, everybody. This is Tyler Lay, and we have a great episode with you today. I'm here with Diane Hartley. Yes, Diane Hartley. You don't know who she is? She is the long lost student from the Citicorp Center, or at least the most likely probable. We're pretty sure it's her. She's got an amazing story for you, some inside information about the Citicorp Center, how it happened, what it was all about. And I'm excited to get started. Diane, thank you so much for being here. Please tell us a little bit about yourself.
Well, thank you, Tyler. It's great to be here. And thanks for your interest in me and in this interesting project. So, I'm a married, working mother, real estate consultant, living and working in Washington, D.C. And I was born in Schenectady, New York, grew up in Bergen County, New Jersey, and went on to study architecture and then engineering at Princeton. Later on, got into real estate development after picking up an MBA. And moved to Washington, D.C., and I've been here ever since, and loving life.
That's awesome. So now tell me about your story, how you became an engineer. I mean, you said you started out in architecture. Tell me about that change between engineering and architecture.
Yeah, that's right, Tyler. So I started studying architecture at Princeton. It was in the mid-1970s, and I always had a passion for buildings and design and math and science and cities. So I thought architecture would be a great fit for me. But after my sophomore year, I realized maybe the fit wasn't perfect. I had a sophomore studio with the darling of the architecture industry at the time, Michael Graves, and looking left and looking right at the other students who seemed to be really thriving, and I suddenly felt like a fish out of water. And at the same time, I took a survey of engineering course called Structures and the Urban Environment that was taught by just a fabulous professor at Princeton in civil engineering, a guy by the name of David Billington, who inspired me to look at the built environment like no one ever had. So after a summer job where I was typing, but actually working for an engineering company, my boss took me out for lunch to thank me for my work and said, hey, Diane, if you haven't ever thought about it, you seem to have a head for engineering. Maybe it's something you should look into. So, excuse me. So that fall, when I went back to school, I ran over to the registrar and changed my major to engineering, which turned out to be a much better fit.
Well, that's such a cool story. I mean, it's so cool that you got encouragement from people at your workplace so that you could learn that. I think that doesn't happen enough these days. And it's such cool that you have ties to Billington. I mean, author of The Tower and the Bridge. I mean, amazing structural engineer. I mean, been very influential on me, and I know a lot of other people. And I think his name's probably going to come up again. The next question is there's a lot of legends about the Citicorp Center, things that I don't know if anyone really totally knows what's true. And I think in some ways that makes the story even more exciting. But it sounds like you played a pivotal role, or at least you were somewhat involved with it. I'd like to hear the details. I'd like to hear what happened, your side of the story, and tell us how you were involved.
Sure. Well, again, no one really knows 100% of the story, of any story, but I can tell you my side of it. And studying engineering and really being heavily influenced by David Billington, of course, at Princeton, doing an undergraduate thesis is really an important part of the educational experience. It's actually required. And David Billington had a wonderful paradigm, a three-part paradigm for looking at important urban structures and helping break things down and really helping folks understand what are the important features of that structure. And so he would break things down into the scientific, the social, and the symbolic aspects of the project. So when it came time for me in my senior year to do my thesis, it only seemed natural that I should go back and ask David Billington if he would be my advisor. And he said yes. So I was really excited. So then I went out to look for a good subject project to study. And one of my former architecture classmates suggested that I take a look at the Citicorp Center, which in 1977 had only just been completed and was still being occupied. So this was a tall structure at the corner of 53rd and Lex in Manhattan that was the new corporate headquarters of Citicorp. And it was important for a lot of reasons. And getting back to Billington's paradigm, from a scientific standpoint, the building had a very interesting structure. It was interesting in many ways, but the two most prominent features were it had a tune mass damper located at the top of the building, which helped the building withstand simple wind loads. And by putting this damper, which would kick in and move when the building was swaying in the wind, it enabled the structure to be built more cheaply, more efficiently, more effectively, using less material, just made for a lighter structure than would otherwise be required, which also made the building, interestingly enough, more flexible. And then another interesting feature of the building was that because of the need to accommodate on the building site one of the pre-existing occupants, and that was a church that had been on the corner of the lot that was assembled. They wanted, for a number of reasons, a lot of symbolic reasons, a lot of emotional reasons, to go back to that exact location, but they wanted a freestanding structure. So the building engineers were able to come up with the idea of locating the four primary columns of the square floor plan, not in the four corners of the site, as they more typically would be, but they located them mid-block, and therefore enabled the structure to be cantilevered up and over the church that could go back and occupy its original site. So in addition to being really interesting from an engineering perspective, the Citicorp building was important for other reasons. And of note, Citicorp had decided to relocate its headquarters back in Manhattan, bucking the trend of many companies at the time that had been fleeing Manhattan. And the city had passed some innovative zoning regs that enabled all of this to come together. So it enabled locating the columns mid-face. It enabled by cantilevering the structure out over the corners and opening the corners of the lot for public space or for the St. Peter's Church to relocate. They got bonus density, and that enabled the building to be built taller than it otherwise wouldn't have, and thereby creating a new skyscraper on the Manhattan skyline. And with the tune mass damper in the roof, they put an interesting cant to the roof to make it stand out even more so. So for all reasons, this was a very innovative structure for the zoning, locating the church as part of the commercial project, the tune mass damper, and these interesting multi-story columns that were located mid-block.
That's amazing. How did you investigate it?
So I did some preliminary research on the building and got it okayed through Billington. And in January of 1978, I jumped in. Now, again, my research was going to be looking at the scientific, social, and symbolic aspects. And as part of this, as kind of a precursor, David Billington suggested that I really take a hard look at the history of tall buildings in Manhattan. So really the first part of my work was a historical review of how engineering and technology and material science developments had enabled buildings to go taller and more efficiently, more cost effectively, and produce more interesting business opportunities for corporations that were going to be owner occupiers and also real estate developers. So that was really the start of my work. But I very quickly realized that I was going to need some behind the scenes information about the engineering aspects of the building. So I reached out to the building engineers, Le Mesurer, in Cambridge, Massachusetts, and they introduced me to their project office that was located in Manhattan. And I finagled an invitation up to Manhattan. I visited Citicorp. They were only happy to, more than happy to talk about the building. They heard about my project, and they actually offered me, I was so excited, a $10,000 stipend to turn my thesis into a coffee table book after it was completed. So I was just
No
thrilled.
way. $10,000?
$10,000, which was a lot back then. That was like an first year engineering starting salary. So that was bonanza. So I was really excited about this. And then at the same time, the engineers welcomed me into their office. I met with the project office head and the junior engineer that had done the calculations. And I left their offices with copies of calculations, full-size set of structural blueprints, and went back to Princeton to continue my work. So working along, and I think it's important to understand that my thesis was a big undertaking for me, and unfortunately, because I had changed my major from architecture to engineering kind of late in my studies, I had a very heavy course load. I was taking sometimes prerequisites with departmental classes, and whereas most students had maybe 2 or 3 courses their senior spring semester while they were finishing their theses, I had, I think, as many as 5 or 6. So I had a crazy workload. Things were kind of a blur, and let's say we put in a couple of all-nighters trying to get things done. So was working on my thesis, had my final draft in hand, and I had put off, since I had all the calculations and drawings, really taking a hard look at that aspect of the structure. I'd taken a long, hard look at the tune mass damper and the dynamic analysis of the building. But in terms of more the static and the wind loading, I thought that was a bit simpler, so I had put that off until the end. So here it was, March, late March of 1978. My thesis was due somewhere the first week of April, and I was getting down to the wire. So I started doing my technical evaluation of the building, which really entailed my replicating the design calculations and comparing the design to stresses, which the ones that were noted on the structural drawings. So was working along, and a lot of my calculations I found very easily matched the design calculations I had been provided. And I discovered, based on my analysis, that it was the cornering wind condition that would produce the highest design to stresses for the primary columns and the innovative chevron bracing that they supported. However, when I looked at the design to stresses noted on those chevron members and columns on the construction drawings, the numbers were lower. They were about 40% lower, and it just didn't make sense to me. So I thought about it. Time was short. I was going to call my thesis advisor, but I was a little bit behind schedule, so I thought I would go back to the source. So I picked up the phone and called the project office of Le Mesureur in Manhattan, and basically talked through what I was seeing from my end and what I saw in the drawings, and asked for help in trying to reconcile why I was coming up with higher design to stresses than were shown on the drawings. And frankly, although it didn't make sense to me, the response I got was, this is well and good, but because of the location of the columns, because given a quartering wind and the overturning, the line of overturning, there would be two columns resisting, and therefore the building was twice as strong. So it didn't make sense to me, but I made a note in my thesis and I moved on. Well, I think the proper response would have been, even though there are two columns in resistance giving the overturning moment from a cornering wind, since those columns are located much closer to the line of overturning, they really needed to be much stronger. So, but given where I was, I made a footnote, made my notes, and finished my thesis, turned it in, and enjoyed my graduation festivities. Then, just a couple weeks later, after recovering from that, I started calling Citicorp, hoping that I could cash in on my stipend to turn my thesis into a book. And woe is me, I couldn't even get them to return my calls. So I was frustrated. I thought maybe they just moved on. I waited a while. I sent a letter or two. By July or August, I was forced to kind of give up with the fact. So I started looking for a real job, and I moved on from there and actually got a job, great job actually, working for T.Y. Lin in San Francisco.
Oh, that's great. Oh, T.Y. Lin, amazing company, amazing bridge engineer. That's amazing. That's what a story. So you told me about we've turned the thesis in, you go to work for T.Y. Lin, and then at what point do you realize that there was some kind of post work done on the building to strengthen it, to address just what you brought up? I mean, really, to address that 40%, overstress or whatever for those columns. When did you hear about that?
Well, it was really much later. And so, fast forward. So I graduated in 1978. In the late 80s, I actually went back to school and picked up an MBA and moved into the real estate field. And that's really where I've been working ever since, commercial real estate. So I wasn't really living and breathing engineering and structures the way I had been. I married my college sweetheart, John Sade, and we took up residence in Washington, D.C., started a family, and we had just only recently welcomed my younger son, in 1994. And I was upstairs in our home putting him to bed one evening, and John was downstairs in the family room watching TV, and all of a sudden I heard this whooping and hollering, and he said, Diane, quick, turn on PBS. Your thesis building is on TV. So I turned on the TV and was absolutely stunned to see a documentary about the Citicorp Center. And when I turned it on, they were talking about the fact that it was only after the building had been built and occupied that they determined that the building had been under-designed. And it was the cornering wind situation that they hadn't recognized as being important to the design of the building. And
then that's your story. That's like your thesis.
Oh, no.
That's like the connection. That's amazing.
Oh, no. I was just totally amazed. And then they went on to say Le Mesurier had gotten a call from an engineering student in New Jersey, some guy who thought he should call him up and ask him why the structure had funky column locations. So, of course, I said, well, there was some guy in New Jersey also studying the building, and he thought to call Le Mesurier. Good for him. But really, I was just totally amazed that this all came to be. And at the time, I didn't actually have a copy of my thesis. It was stored away someplace. So it was really years later that I got my hands on it. And when I looked and it all came back to me of how that one aspect of the cornering wind hadn't made sense at the 11th hour, and I'd had the phone call with the engineers at the beginning of April, that I realized it might have been my call that had something to do with the discovery. And I
That's
at least
really cool.
understood why the stipend from Citicorp went away.
Yeah. No kidding. Because a major bank doesn't want people to kind of know that their building could have or might have or whatever have had problems. That's
Exactly.
interesting. So how does it make you feel that your questioning or, your thesis, your efforts, could have averted a tragedy and saved so many people's lives? What was that like?
Well, it's kind of awesome. We don't really know for sure. So there's that aspect of it, which I think tempers everything. Certainly, every once in a while I meet people that are just totally amazed and want to give me a hug or say thank you and what have you. But if it's true that perhaps the most impactful thing that I've done with my life, I didn't know I was doing at the time, well, that kind of puts it in perspective.
Well, that's a cool thing to say, but I'll tell you, by having children and doing what you do every day and putting this story out there for other people to learn from, your impact is still being felt and still going on, and so thank you so much for that. But does it bother you that you didn't get any recognition? Does even a little bit of you feel like maybe I should have been on that PBS special? Maybe,
Well, I've never really felt that way, but I really wish I would have gotten better feedback about why that stipend wasn't coming. At the time.
Maybe the $10,000 would have made you feel a whole lot better, right?
Well, there you go. But I will say it has been fun over the years. Every once in a while, this story is used not only in education of engineers, but also in ethics and legal ethics and government and so forth. George Will cited this story in a column not too long ago. So, I've had the experience of being in an audience where someone on the podium will point to this as an example. And both of my kids, one of whom actually went on to become an engineer, have also had instructors and professors point to this as an example of either ethics or checking your work or always asking questions and so forth and so on. So I know they've gotten a kick out of being able to raise their hand and say, that was my mom.
I bet. Man, what a cool story. Thank you for being so brave, and thank you for asking questions. We're not totally sure if it was you or not, but I'm convinced it was you. And so thank you so much. So are you naturally a curious person? Is this like asking a bunch of questions? Is that something you usually do, or was it kind of different this time?
Well, I think I've always been a little curious, but as I mentioned before, when I started studying engineering, it seemed like a good fit. And I think that's because I've always been someone who's been a problem solver. So given a challenge, I like to figure out what the solution is. And I think, working on this project and looking into the history of it, maybe if anything, I wish I could have been part of the solution. But I think it always, one of the legacies of David Billington was his ability to break down into very simple terms some of the important inherent structural principles by which either a Maillard Bridge or Nervi Stadium that seem to defy gravity could work structurally, so that the average person, someone who hadn't studied engineering or math or science or physics, could really understand how it worked and really understand the beauty of the structure, because a structure that's well designed and efficient, there's a beauty in that, especially when you see the stresses and how the structure works portrayed in that structure. So I think that is something that I think Billington's legacy and his association with this, and the fact that it was his very simple paradigm for how you look at and dissect and break down and appreciate and understand some of these big important urban structures. That's a legacy that hopefully will go on and continue. And people who study this building will be prompted to look more into Billington and maybe read some of his books, or at least do some research on who he was, and many of the professors that are out there even to this day who were his students, who have captured some of this analytic technique.
No, I totally agree. I think that's amazing, and I think you're right on. I love how you put it, defying gravity. And I think he was a big fan of structural art as well. This idea that things should be aesthetically beautiful and pleasing, and how they fit. And I think it's just really elegant the way you put it. And he must have been an amazing professor for you, because he obviously made an impact on you, and you've made an impact on so many other people. And I think that's a really cool story. So, is there any other lessons that you learned from this experience? I mean, you just gave us this great answer about Billington and his influence on you and whatever. Is there anything else that I guess you take away from this?
Well, and you were asking about questions and curiosity, and I think we should never stop questioning. And I'll share, and you might not know this. There's a team of engineers currently at NIST that's been looking at the building, looking at Citicorp again, using modern analysis techniques to try to determine whether the way we were looking at it back in the 1970s was really the correct way, and whether this concern about under-design was even valid. And they've put out a hypothesis saying maybe the building was okay after all. and maybe it was just over-designed after all. So I think that sort of second look and third look is good and shouldn't stop. And it's how we learn, and it's how we improve structures, really, in engineering going forward.
Yeah, no, I agree. I think you got to always be questioning, and I think that's a good thing, a good lesson for all of us, is that sometimes we're apprehensive or we're scared, or we think we're going to look stupid in front of other people. We think everyone else already knows the answer. But I'll tell you what I find is that if you have a question, there's probably lots and lots of other people with the exact same question. And that if you should ask it, then I think that's some of the best parts of lectures and discussions and everything else is the question and, you know, reflection. So thank you for that. So where can people find more about you? You know, you're obviously a successful real estate person now, right? And if people are in the Washington D.C. area, they may know you. But where's some place that people could find more about you and kind of what you're up to?
Well, I don't have a website. I don't advertise my work. Most of my clients, I do a lot of work with the federal government, and so a lot of folks know how to find me, know when to call. So again, I don't have a website, but I will say that if you want to reach out, I'm always happy to talk and meet folks in the industry. People are always doing articles or asking for my perspective when they're teaching this story for various reasons. I'm always happy to talk. So feel free. You know, I'm Diane Hartley at Hartley LLC. You can find me on LinkedIn. You can find me at Twitter at Diane Hartley. Pretty simple.
Nice. Okay. Awesome. So do you have any other message that you'd like to share with the audience? Any parting thoughts?
Wow, that's a big ask. Thank you. But actually, no, I just say, you know, you talked about Billington and structural art. I would just say, if you haven't, if you don't know David Billing, if you haven't heard the concept of structural art, look it up. His work is still ongoing, as I mentioned, at Princeton. Professor Maria Garlock is taking it forward to the next level there. And I think if you take a look, you'll enjoy.
Well, thank you, Diane, so much for your time. Hey, everybody, I hope you enjoyed this interview. I was blown away by it personally. If you did, leave us a comment below. Please give us a thumbs up and think about subscribing to the channel. As always, thank you so much. Take care, everybody. Bye.